Well, hello everyone. The title of my talk today is Verifiable by All. And what I'm going to talk about specifically is why verifiability is at the core of what makes blockchains decentralized and secure, and specifically why a new node type called a light node that's enabled by modular blockchains makes blockchains for the first time verifiable by anyone. So it opens up accessibility and makes blockchains more decentralized and secure. So you may have seen, if you're on crypto Twitter in May, a bunch of memes that were circulating of people running light nodes, pieces of paper or in a club or on the COVID test. And people were having a lot of fun, memeing the Celestia light node. And I was really glad to see that everyone was embracing this idea of running a Celestia light node, but I wanted to make sure that the significance of light nodes was not lost amongst the humor of these memes. And so to understand why light nodes are so important to blockchains, and I would even say to sort of the future of humanity, we had to kind of zoom out a little bit and get high level. And I want to start by sharing a quote from Yuval Noah Harari, which is that humans have the unprecedented ability to cooperate flexibly in large numbers. And this is probably something that you don't think about very often, but one of the things that makes humans special among all the different animals is that we have the ability to work together in groups. And by cooperating and working together, we're able to do things that are much more powerful, and we're able to create a better world for ourselves. And this is kind of a good way to understand this is by thinking about the difference between a single-celled organism like a bacterium and a multicellular organism like human beings themselves. And so when in biology, when cells cooperate and work together, they're able to create organisms that are far more powerful and complex. And there's a similar thing happening, at the human level. When human beings get together and cooperate, we're able to do things that are more powerful and complex. Now, in nature or in the wild, in their natural state, human beings are limited in the sort of the number of humans that can successfully cooperate together. And this is the so-called Dunbar number, and it's around 150. And fortunately, we've been able to transcend this sort of built-in constraint of only being able to cooperate in a group size of 150. And this is one of the things that has actually led to our ability to sort of expand and grow as a species and create more prosperity and well-being for everyone. And so one of the arcs of history is that, and I'm going to introduce a really important concept here, which is social scalability, which is the number of humans that can successfully cooperate in a given system. And one of the arcs of history has been that over time, human beings have been able to grow and increase social scalability by creating new technologies of cooperation. So, in the ancient times, we cooperated at the scale of tribes. So maybe, on the scale of hundreds of people or so. Then as time progressed, we started being able to cooperate at the scale of city-states, maybe tens of thousands or hundreds of thousands of people. And now in modern times, we're able to cooperate at the scale of nation states, or, on the scale of millions, tens of millions, sometimes hundreds or even billions of people. And we've gotten this far and created this a world where we have more prosperity and we're able to do more powerful things like, launch rockets up into space, because we have legacy technology of cooperation. And the way that legacy cooperation systems work is that you start with a set of rules that everyone in the system agrees to follow. And unfortunately, you can't stop there. You can't just trust that everyone in the system is going to follow the rules. So you have to empower another group of people, the rulers, who are meant to enforce those rules on everyone else. And this works pretty well. I mean, it's gotten us to where we are today. But unfortunately, it has a deep-seated problem within it. And that is that it's summed up in this question: who watches the watchman? So in other words, who is enforcing the rules on the rulers? There's no one there to watch over their shoulders and make sure that they're actually, following the rules themselves, or that they're not arbitrarily enforcing the rules on people that they favor for their own benefit. And unfortunately, they have an incentive to cheat, right? In a system of cooperation, if you can cheat, you can extract more value for yourself. And this is what corruption is. This is what fraud is. It's people who are breaking the rules for their own benefit. And we got a very good, unfortunately had a sort of like recent example of this in what happened in FTX. And a lot of people took FTX and what happened as an example of what's wrong with crypto. But in fact, it's actually an example of what's wrong with our legacy systems of cooperation, because FTX is a legacy institution. And it's more an example of why we need blockchains in the first place, because we need to decentralize and build something better than what we currently have, where our trust can be exploited. And so this is a really important concept, which is that trust in a system of cooperation, trust doesn't scale. When you have to trust someone or a group of people, then that becomes a sort of a security hole in the system. It becomes a place that the point of exploit, where someone can capture that point, then they can break the rules, right? And then they can sort of abuse the system of cooperation to their benefit. And that's why in the blockchain space, we're always using words like trustless or trust minimized. It's because what we're trying to do is build systems that are more socially scalable by removing trust. And that brings us to how blockchain cooperation systems work. And the way that blockchains work is very different to our legacy system, in that you have a set of rules, again, that everyone agrees to follow. And then rather than having a set of rulers that enforce the rules, it's actually the people, the users, the participants in the system who enforce the rules on each other. And this is really, really a totally different dynamic, basically, because you no longer have this central party that is empowered, and everyone is on the same footing. Everyone is equally empowered and powerful in the system, so that there isn't a central point that can abuse its power on the rest of the system. So how does this work? It sounds kind of too good to be true. Well, and I should also mention, this is not, it's really important that people realize that validators or miners in a blockchain system are not the ones enforcing the rules. And this is a really common misconception. It's actually, if it were the case, then we would just be kind of repeating the same patterns of legacy cooperation systems. Everyone would be trusting the validators to do the right thing, but no one would be there to actually enforce the rules on the validators. So that's not how blockchains work. And to explain how blockchains do work under the hood, the way that users are actually able to enforce the rules themselves is by running a node of the network. So what a node is just a computer program that knows what the rules of the chain are, and it constantly audits and verifies everything happening on chain to make sure that things are following the rules. If anyone tries to break the rules, then that block is ignored, and the fraud or whatever kind of malfeasance was trying to happen is stopped before it can even take place. So this is what enables the core value proposition of blockchains, which is they enable rules without rulers. So you can have a set of rules without having this privileged group to enforce them on other people. And this enables us to scale cooperation to the planet level scale, because you're replacing the need to trust individuals or groups of people with the need to just trust in cryptography. And that way you can actually connect everyone in the planet through a sort of a shared network of cryptographic trust. And this is the promise of blockchains, of what they can achieve and do for the world. But unfortunately, there's a problem, and that is that blockchains are not very technically scalable. So what I mean by technical scalability is the number of transactions that a blockchain can process per unit time. So blockchains inherently have a limit to the number of transactions that they can process. And that's because running a node is very inefficient. So if you're running a node in a monolithic system, like all the blockchains that currently exist today, you have to download all the data. You have to download every single transaction, and then you have to verify every single transaction that happens. And unfortunately, if you're a user, you may have a phone or a laptop or whatever like device you have has only a certain amount of bandwidth to download transactions, and only has a certain amount of computing power to verify these transactions. So at a certain point, you can't download more transactions and you can't verify more transactions. So this sets a limit to the amount of transactions that the overall network can process. And so that makes it so that you have this finite capacity of throughput of the system. And so this kind of like in many blockchains basically make a trade-off, which is that they say, okay, well, if not everyone can run a full node on their phone or their laptop, that's fine. They can run a light client, and we can increase the number of transactions that we process, that so-called scaling, but sacrifice actual social scalability by forcing people to run a light client rather than a full node, which is actually verifying the chain. And the problem with a light client is that it actually reintroduces trust in the system, because people who run a light client rather than a full node actually make a trust assumption on the validator set. So it kind of breaks the value proposition of blockchains in the first place. So you can see that there's kind of like this deep paradox or sort of dilemma, I would say, between social scalability and technical scalability. So on one side, you can have a blockchain that is very socially scalable because it limits the amount of throughput that it processes so that anyone can verify the chain. But then it's not very technically scalable because it can't process that many transactions. Or you can have a blockchain that's very technically scalable. It processes a ton of transactions, but it does that by increasing the cost for an end user to run a node. And therefore, it prices a lot of people out from verifying the network and becomes less socially scalable. So this is sort of the dilemma of I would say, of the monolithic blockchain era. And unfortunately, this means that we can't actually achieve the full potential for blockchain technology, and that neither of those systems actually scale to the planet. If you can only process 15 transactions per second or so, then not everyone in the planet can actually use this system. Or if you process a ton of transactions so that everyone can use it, then no one can verify it. So then you're not actually building this cryptographic network of trust that anyone can use. And so this is really like the core problem of blockchain scalability. That is, it was until this guy, Mustafa Al-Bassam, who was just up here, published 2 white papers in 2018 and 19, where he described a new way of building blockchains, a new way of verifying blockchains, which is modular and uses some new technology that makes it significantly more technically and socially scalable. So the way that it works is that in a modular blockchain world, rather than downloading every single transaction and verifying every single transaction one by one, you simply download a tiny sample of the data, and then you can verify a single proof that all those transactions were executed correctly and that they're valid, and you can verify them. So what this means is that as the number of transactions that the system needs to process increases, the amount of work that you have to do to verify does not increase at the same rate. So this makes it so that we can actually have a system where we can process more and more transactions without pricing people out of being able to verify the network. And this enables this new node type that I was talking about, which is a light node. And a light node has achieves a similar level of social scalability of a full node, with a similar level of technical sort of like scalability of a light client. So you don't have to make this trade-off anymore. You can actually have a system that achieves both of these properties at the same time. And you can see this represented in the node requirements of Celestia versus other blockchain nodes, and see that in many cases the sort of the requirements are an order of magnitude or more less than these other systems. And we believe, and I think this is a core value not just of Celestia but of the entire modular blockchain movement, that it's important that anyone, anywhere, should be able to run a node and verify the chain directly. And that's why we targeted the specs for running a light node to be compatible with running it on mobile devices, because mobile devices like smartphones are the most common and ubiquitous device in the world. It's an estimated like 5 billion people have a mobile device worldwide. And so if we can empower anyone in the world to run a light node on a phone, then all 5 billion people that own a phone could theoretically be connected in this cryptographic network of trust. And then we can actually scale this system, this blockchain cooperation system, to the planet. And it can be a system that everyone can use because it's technically scalable, and everyone can verify because it's socially scalable. And so we can actually, using modular blockchains, achieve this grand vision and state for what blockchains can enable. Now, this is really exciting, and obviously I'm very passionate about it. I think everyone in the Celestia team is very passionate about this vision, but the truth is there's still a lot of work to be done. So I made this slide as sort of like a depiction of all the different layers of the stack that need to come together and be built out in order to enable this vision to work at scale. We know that it's technically possible, and we have the first versions of lots of these things, but there's still a lot of work to be done to build them out to a level where it will actually work at that scale. And so this is sort of a message to all the protocol builders out there. If you're interested in this vision, there's tons of great work to be done, and this is a great time to get into the modular space while things are still so early, and there's so many great wins that we can have. A second part of this that needs to change in order to make this vision a reality is that we need to reduce the friction for people to run light nodes. So currently, the most common way to run a light node is using command line, and unfortunately, not that many people in the world actually know how to use command line. And so we need to make it into user-friendly applications that you can just download, make a couple of clicks, and be running a light node. And people like Josh on our team have built apps like Quasar, which I encourage everyone to check out, which makes this extremely simple to do. And I think in the future, light nodes will be embedded in people's crypto wallets and in the browser when they're using applications. And in that way, we will actually have these systems be verifiable by default, similar to how the privacy movement has a private by default. And last but not least, actually, we going back to the beginning of the talk, we need to make light nodes into a meme. We need to make them into a part of our culture that everyone actually runs a light node. It's kind of like a rite of passage. It's almost like, if you want to join this movement, the crypto movement, you have to run a light node, and that's kind of how you get baptized into what crypto is all about. And fortunately, the meme has been working, and a lot of people have been running light nodes in lots of different places in the world. On airplane Wi-Fi, the pyramids, or in a remote place in Vietnam. People have also been running light nodes on all different kinds of devices like Kindles or Nintendo Switches, and even someone ran one on their car. And so this is all great, but you might be wondering, why should I care? Why should I go through the effort of running a light node? I only have so much time in my day, and this just sounds like a lot of work, and does it really matter, right? And the answer is that you should care, because we're living in a world where people in power are increasingly, our rights are increasingly being infringed upon by people in power. And we've seen a lot of examples of this recently, like recently in Canada, there were the Canadian government used the banking system as a way to suppress protests. So they kind of weaponized the financial system. We've also seen leaks about how there's censorship on social media and there's widespread surveillance throughout the internet by governments. And I don't think it's a coincidence that trust in our institutions is at an all-time low, because I think people are waking up to the realization that the people in power don't always have your best interests at heart. And this may sound like a very sort of negative message, but the reality is we're really lucky, because in the past, our ancestors, when they had to stand up for their rights and what they believed in and what they deserved, they had to go to war. They had to fight. They had to put their lives on the line and fight against their oppressors or whoever, fight against corruption. And the beautiful thing about blockchains is that they give us an alternative. They give us a non-violent path as a way for us to actually enforce our rights and claim back our sovereignty. And so rather than having to go to war, all we have to do is just run light nodes and use blockchains as a way to enforce our rights in a non-violent way. And I think that's really powerful. But even beyond that, light nodes are not just about fighting back, but they're also about taking the next step forward in the evolution of humanity, in that we can, using blockchains and light nodes, create, the next scale of cooperation and the next sort of build a more prosperous, democratic, and peaceful society going forward. So I want everyone to, if you have a phone on you, just pick it up and realize that what you're holding in your hand is not, a phone or a camera or a computer. It's actually the key to your rights. It's the key to digital freedom. And it's also the key to a better future for humanity. So thank you very much. Hopefully you're inspired to run a light node and inspired to be part of the modular blockchain movement. Thank you, Kartik. Yes, we have a big week coming up.